Hello and welcome to Chapter 11, and we're going to talk about capital budgeting. So we're going to go through net present value, IRR or internal rate of return, what is known as MIRR or modified internal rate of return, two different payback methods, the regular or the discounted, and finally, what do we mean by multiple IRRs? So companies do capital budgeting anytime they want to make decisions about a project. So some examples would be analysis of potential additions to fixed assets, and generally capital budgeting involve long-term decisions, large amounts of money, large expenditures, and they are very important to a company's future. So when you're engaging in capital budgeting analysis, realize it's generally a very important thing because this can have wide-reaching consequences of the future of a company. Some steps of capital budgeting are the following. We're going to estimate our cash flows, anything coming in and anything going out, determine how risky those cash flows are, determine an appropriate cost of capital to use, find our net present value or IRR or internal rate of return, and finally, we're going to accept a project if that net present value or what it's currently worth in today's money is greater than zero, or if our IRR or internal rate of return is greater than our cost of capital, meaning the project will return a greater percentage than it's going to cost us to use the funds. So those are two scenarios, NPV and IRR, which can determine whether or not to take on a project. When we are making decisions as a company, we may run into what are known as independent and mutually exclusive projects. An independent project is one where cash flows are unaccepted by whether or not we take another. So if projects are independent, if we are proceeding with project A and we're studying project B, whether or not we take project B has nothing to do with project A. It won't affect our cash flows from it. Mutually exclusive projects are projects where we have a choice. An example of that would be we have one factory and we could build smartphones or laptops at it. Regardless of what we do, it's mutually exclusive because we can either tool up the factory to build smartphones or we can tool it up to build laptops. That's an example of a mutually exclusive project. If the cash flows of one can be impacted by acceptance of another, so that would be an example. It may not always be a black and white example like that. It might be we have to cut production of one to take another, or something where you fully go with one or the other. The one factory example is easier to highlight it. So when we're looking at cash flows, and we're going to look in a moment at our next slide, we talk about what are known as normal and non-normal cash flows. Normal cash flows generally look like this. You have a cost, meaning whatever we're going to spend to take on this project, the equipment or anything else. So we have a large cost at the beginning, and then a series of positive cash inflows, one change of signs. So we invest a bunch of money, and then we're going to have positive cash inflows come in. That is an example of a normal cash flow stream. Non-normal cash flow would be multiple sign changes. So we may have a large expense at the beginning, then make some money, then a few years later have more expenses, then make money again. That's what's called non-normal. The most common is the following. Your cost is a negative cash flow, and then a string of positive cash flows, and then some sort of cost at the end to wind the project down. So things like a power plant or a mine, those are all examples of this. We're going to have a large cost to build it, make a lot of money for a certain amount of time, and then when it becomes obsolete or no longer usable, there'll be a cost component to winding it down. Just like we've done previously with time value of money, the net present value of cash flows is simply the sum of the present values of all of your cash inflows and outflows of the project, utilizing our discount rate, or R. R here is usually going to be our weighted average cost of capital. And we're going to discount all of those cash flows, positive and negative, to arrive at a net present value. Or what is that project currently worth to us? That project's NPV is basically the present value of all of the cash flows, positive and negative, what is it worth to us in today's money? That's our net present value. And when we get our net present value, what it tells us is, does it seem to be something that's going to make us money or not? If our net present value is positive, it's going to be a project we're going to want to take on. And if it's negative, we're not going to want to take it on. You're never going to want to take on a project with a negative NPV. So we could look here at a project. So we have two of them. We have L and S. Project L and S both cost $100 in year 0, so that's what we have to spend to initiate them. Project L is going to pay $10, $60, and $80 in the next 3 years. Project S, $70, $50, and $20. So delta cash flow, or difference in the cash flow between them. In year 1, Project S is making you more money. In year 2, Project L. In year 3, Project L as well. And if we sum total these, we're going to get 80 plus 60, or 140, plus 10, or 150. This one here, 70 plus 20, 90 plus 50, 140. So Project L is going to give us slightly more money, but Project S is giving us more money sooner. So we're going to take a look at our present values. What we would do here is put them into Excel. You would use the equals NPV formula. At our equals NPV formula in Excel, we would then simply enter our cash flows from year 1 to 3. So we would enter these guys right here. And our rate is our cost of capital, 10%. Now, why are we adding cash flow 0 in at the end? Why aren't we putting that under the NPV formula as well? Because cash flow 0 is today. There is no present value. Since it's in year 0, it's happening right now. Money is worth exactly what it's worth right now. There's no discounting that we need to do. So you find the present value of cash flows 1 through 3, 10, 60, and 80, discounting it by 10%. You can use a financial calculator, but as I've said many times, I would recommend utilizing Excel. Formula is equals NPV. Rate goes first, and then cash flow 1 through 3. And then add, simply just add cash flow 0. We do not discount cash flow 0 because it's happening right now. And our NPV here is positive. I believe these numbers are all in thousands, but regardless, you have a positive NPV, 18.79, or if it was in thousands, 18,790. And what this is telling us is this project is going to make us money. As long as NPV is a positive number, it means the project is going to make you some kind of profit. So as long as it is a positive number, it's going to make you some sort of a profit. If it's negative, you would not take a project on. Why? Because it means it's going to lose you money. So as long as NPV is a positive number, it is in your interest to take on that project. It's going to make you something. That's what a positive NPV means. So if we want to look at the other one, Project S, we do the same thing, add cash flow 0 at the end, and find the NPV of the regular cash flows. Cost of capital is still 10%. And your NPV here is higher, 19.98. So you have a higher NPV for Project S than Project L. So if you had to choose between the two of them, you would take Project S, meaning if they were mutually exclusive. If they weren't mutually exclusive, if they were independent and we had the ability to take on both, well, in that case, you would take on both because both of them have a positive NPV. As long as you have a positive NPV, you're going to take on a project, unless you are torn between the two. If you have an example like I gave before with the factory, and we could either do S or L, you would take on Project S due to the fact it has a higher NPV here. If you wanted to use a financial calculator, this is how you would do it. You would enter them into the cash flow register, enter your interest, and hit your NPV button. Financial calculators are perfectly fine to do this as well. I would just recommend for ease of use Excel, but if you want to use a financial calculator, you're welcome to. You'll get the exact same answer. So what's some of the rationale for the NPV, or net present value method? So net present value is the present value of all of our inflows minus the cost. So net present value of our inflows minus the cost, and it gives us our net gain in wealth. As long as NPV is positive, it's in your interest, if you can, to take on this project. It means it's going to make us money. So if they're independent, as long as NPV is greater than 0, take the project. So both of the ones we just looked at had an NPV that was larger than 0. If they were independent and we have the resources to take on 1 or 2 or none, we would take on both, because both of them are greater than 0. If they're mutually exclusive, however, that means you're torn between the two of them, except the one with the highest positive NPV, or the one that gives you the most value. In this example, if they're mutually exclusive, you would take S, because S had a higher NPV, as we just saw. And if they are independent, you would take both, because both are going to make you money. So that's the difference if you see a test or a homework question asking you about cash flows. If they're mutually exclusive, you're going to want to take the one with the higher NPV. If they're independent, you would take both, provided they have NPVs larger than 0. So what's IRR? So IRR is the rate of return, or the percentage return that we're going to make by taking a project. And what I would recommend doing in Excel is equals IRR. And you would just enter your cash flows in order, starting at 0 and going to your last one. That's why it says cash flow 0 to N. And a guess for the rate. The guess for the rate is, once again, our cost of capital. So in these examples, we use our weighted average cost of capital for our rate. So you would put in 10%. And if we did that for both, Project L, 18.13, Project S, 23.56. So it looks like Project S is going to give you a higher rate of return, and it also consequently had a higher NPV. Now, with the IRR method, what are we going to do? We're going to compare our rate of return to our cost of capital. If you have a rate of return that is less than your cost of capital, it means you're losing money. It means that it costs more to get the funds to use in the project, whether or not we're borrowing them or using retained earnings, than we're going to make on them. So if that happens, you're not going to want to actually use that project. You're not going to want to take that project on, because you're losing money. So how is a project's IRR similar to a bond's yield to maturity? They're basically the same thing. Think of a bond as a project. Yield to maturity is the IRR of it. So if you had a 10-year bond with a 9% coupon and a 10% $1,000 par value, and it's currently selling at $1134.20, if you use the equals rate formula, you would get 7.08. Or you could use the IRR formula by putting in the cash flows. And you would get the same thing. So IRR is yield to maturity. Here would be about 7.08%. So what's the rationale for our IRR method? Remember, if your IRR, internal rate of return, is larger than your weighted average cost of capital, project's return exceeds its costs and there is some left over. So to boost your stockholders' return. So as long as you're going to make more on your money than it's costing you to use it, pretty logical, you would accept the project. If your IRR is less than your cost of capital, it means that you're actually losing money. Whatever source you're getting the funds from, whether or not you're borrowing them or using retained earnings or wherever they're coming from, they're costing you more to raise than you're making with them. So you're actually losing money. Once again, if projects are independent, as long as both of them have an IRR over your cost of capital, take them both. If they're mutually exclusive here, we would take S again, because S has a larger rate of return than L. Now, NPVs are determined by your cost of capital. So if we look here, if you use that NPV formula we looked at a few slides ago and varied the cost of capital, at a cost of capital of 0, Project L is better than S. At 5%, L is still better than S. 10%, which we just looked at, S now becomes better than L. At 15%, S is significantly better than L. And at 20%, L is now negative. That's what the earmuffs here are signifying, whereas S is still positive. So depending on your cost of capital may change your determination or your decision of what project you're going to want to take. So whatever your cost of capital is going to actually alter what project you may wind up taking. So if we look here with independent projects, NPV and IRR always lead to the same accept or reject decision for any given independent project. So as long as they're independent, IRR greater than your cost of capital and NPV greater than 0, you're going to accept, and they'll never be in conflict. And they're showing you the profile here for project L. They're showing you here the profile for project L up to an IRR of 18.1 and an R of 18.1. That's the crossover point. So if a cost of capital exceeded 18.1% for project L, then it would no longer be profitable. You would be losing money. That's what they're showing you here. What is the crossover rate? Find cash flow differences between the projects. You would enter your cash flows into your register and press IRR, and your crossover rate 8.68%. So if you want the crossover rate or the differences between them, you would enter the differences between the two projects or delta cash flows and hit IRR, or do this in Excel, equals IRR, and you have a crossover rate. That means where we go from one project being better to the other. If they don't cross, it means one project dominates the other. It means that one project is better at all possible scenarios. What are some reasons why NPV profiles cross? You can have things like size differences, so smaller project frees up funds for investment. The higher the opportunity cost, the more valuable these funds, so a high weighted average cost of capital is generally going to favor smaller projects. So a higher weighted average cost of capital is generally going to favor smaller projects. Timing differences. Projects with a faster payback are going to give you more money up front, and you can reinvest that money. What do we do with our cash flows coming in? We don't just look at them. We can use them to fund operations, and as a consequence, use them to reinvest. So if we have a really high cost of capital, we're going to have tremendous opportunity costs by simply having those cash flows run up and not be able to use them. So in this case, timing differences, if your weighted average cost of capital is high, early cash flows are very good because it will allow you to reinvest them. What are some assumptions here? NPV assumes cash flows are reinvested at the weighted average cost of capital, whereas IRR assumes they're reinvested at IRR. Assuming cash flows are reinvested at the opportunity cost of capital is more realistic, so the NPV method is generally better. The NPV method should be used to choose when you have a conflict with mutually exclusive projects. The NPV method is assuming that any money we earn is being reinvested at our cost of capital. The IRR method is assuming we're reinvesting it at that much higher IRR in a lot of cases, which isn't always something that's going to happen. So maybe we need a hybrid of IRR that assumes the cost of capital reinvestment. And that is what we're going to look at in a moment, known as modified IRR or MIRR. Generally, managers prefer the IRR to the NPV method because it's easier to report if you're giving a presentation or you're trying to get the board to go along with the project. It's easier to report it using percentages. We're going to make blank on our investment in a percentage sense. That is why they generally prefer the IRR method. But is there a better measure? And the better measure is what is known as MIRR or modified IRR. And it is the discount rate that causes the PV of a project's terminal value to equal the PV of costs. And terminal value is found by compounding our inflows at our weighted average cost of capital. That's a very lengthy explanation for this point right here. MIRR is an IRR that is assuming all of our cash flows are being reinvested at our cost of capital and not the IRR. So generally it's going to be smaller than the IRR if both are positive. However, it's more realistic because now it's doing what we did in the NPV method. We're assuming our cash flows are being reinvested at our cost of capital and not at whatever that IRR is. The reason reinvesting at IRR can be unrealistic, we may have a project that makes a tremendous return, but we may not be able to just simply find another project to pay a return like that. We may just get very lucky. As a consequence, our cost of capital, that's a much more realistic number that we would expect to earn on the money we make. So MIRR is the same as IRR, but it's assuming your cash flows are being reinvested at your cost of capital. And how do we calculate it? Well, use Excel once again. Our formula here instead of IRR is equals MIRR. You put your cash flows in order, starting with 0 and going to N or the last one you have. And then you have two things. You have your finance rate and your reinvest rate. When you're keying it into Excel, assume both are your weighted average cost. So your finance rate is your cost of funds, your reinvest rate, what you'll make on the cash flows you're earning. Set them both to the same number, whatever your weighted average cost is. In this case, our weighted average cost of capital is 10%, and we have a $100 outflow followed by 3 inflows. And if we find the MIRR, I would not recommend doing this by hand, although you can manually discount them. I would use Excel. It will give you about 16.5% if we round to 1 decimal place. And what that is, that 16.5% is what we are going to make on our project, taking into account we're reinvesting funds at our cost of capital and not the IRR. It's more realistic. So why use it? MIRR assumes reinvestment at your opportunity cost or your weighted average cost of capital. That's the big one. It's more realistic. Number 2, it also avoids the multiple IRR problem. And what's the multiple IRR problem? If we have non-normal cash flows, if we have cash flows where the first one was negative 100, then the next one's positive, then year 3 is negative again, you're going to have multiple IRRs. IRRs are going to change depending on the point in the timeline we're looking at. Whereas if you use MIRR, it's the same number for the whole project. So you don't get multiple IRRs if you have sign reversals. Remember, not all cash flows are normal. You do have situations where you can have reversals of signs. And when that happens, you would get multiple regular IRRs. So MIRR avoids this. And finally, managers like rate of return comparisons, and MIRR is much better. Why? Because it's taking into account a more realistic reinvest rate. The reason they like IRR instead of NPVs to do comparisons, it's easier to compare percents. We're going to return blank on our money versus blank. That's why. MIRR is generally the way to go when you're doing this type of analysis. It is, once again, more realistic. So what is our payback period? And this is going to be one of the last topics from this chapter. Payback period is how many years is required to recover a project's cost, or how long does it take to get our money back. Remember, most projects have a large outflow at the beginning. We have to spend all kinds of money to initiate it. Buy the equipment, buy the factory, whatever we're doing, hire the people that are going to work for it. And how long is it going to take us to get our money back from our investment? It's calculated by adding a project's cash inflows to its cost until the cumulative cash flow for the project turns positive. So if we want to do it by hand, what would we do? In this case for Project L, it costs us $100 in year 0. Year 1 we get 10. Year 2 we get 60. So we're just looking at the cumulative here. So down 90 in year 1, 30 in year 2. We have 80 coming in year 3. So now we go positive by year 3. So what would we do? The first 2 full years, and then 30 over 80, or how much of that 80 is required to break even? 2.375 years for L, and for Project S, I'll switch to yellow, 1.6 years. So Project L here has a longer payback than Project S. Project S we're going to pay back faster. The reason being, remember, Project S was paying us more money earlier. You had more money coming in earlier, so it's going to pay itself back earlier. Both of them, however, do pay themselves back before the end of the project, meaning they are making you a profit. So payback is useful. What is one of the problems with payback? One of the problems with payback here is it's not actually taking time value of money into account. Remember, if we think back to what we started with Chapter 5, money's worth more today than it's worth in the future. So that cash flow at year 2, let's say, of $60 is actually worth less in today's money than it is in year 2. And we can look at what is known as discounted payback. Discounted payback uses discounted cash flows rather than raw ones, so we are discounting all of them utilizing the equals PV formula in Excel. So instead of 10, it's 9.09. That's discounted to today's money. Instead of 60, 49.59. Instead of 80 in year 3, 60.11. And we do the same formula, but instead with discounted payback, it's 2.7 years here. So discounted payback is more realistic because it's taking into account time value of money, and it's giving you a more realistic payback timeline. Because even though in a nominal sense, the previous example was correct, the 2.375, money is changing in value. So in a real sense, 2.7 is more appropriate. In this case, once again, it still pays itself back before the end of the project, so it is profitable. Strengths of payback provides an indication of a project's risk and liquidity. How risky is it? How liquid is it? How much money is coming in? And it's easy to calculate and understand. However, regular payback ignores the time value of money. So that's a big problem. Money does change in value, especially at high rates. So if our rates are very high, it could be very affected. It ignores any cash flows occurring after the payback period. And finally, there's no relationship between a given payback and wealth maximization. Just because something may pay itself back earlier, you may definitely want a project that takes longer to pay back but returns a lot more money. So there's really no relationship between this. However, it's a good measure of risk. How long is it going to take until we get our money back on a project, for instance? Discounted payback is going to consider time value of money that we just looked at on the previous slide, but the other two flaws do remain. So if we're looking at this project here, here's Project P. Costs us $800, then makes us $5,000, and then costs us $5,000 over 2 years. What is our NPV? Obviously, we have a negative NPV because we're losing money here. We have more outflows than inflows. NPV negative 386.78. But IRR is going to return as an error. And the reason it's going to return as an error is what I was saying before. You have multiple IRRs here due to a sign reversal. So multiple IRRs are the following. In this case, we go from negative 800 up to 450, then down again. So as we're looking at the NPV, as it's changing, IRR 1 is going to be 25%, IRR 2 is going to be 400%. We're looking at different parts in the timeline. So at first it made us money, and then it's going the other way quite a bit. So if we take a look here, why are there multiple IRRs? At low discount rates, the present value of cash flow 2 is large and negative, so NPV is less than 0. At very high discount rates, the present value of cash flow 1 and 2 are low, so cash flow 0 dominates, which was that large negative charge, and once again, NPV is less than 0. In between, the discount rate hits cash flow 2 harder than cash flow 1 because there can be parts where NPV is greater than 0. So what do we get? We get 2 IRRs because we have a sign reversal. So when you have a sign reversal, when you have non-normal cash flows, generally we use MIRR. So when to use MIRR instead of IRR, and should we accept Project P? So when you have non-normal cash flows and more than one IRR, anytime you have non-normal cash flows, that's what's going to happen. Use MIRR. Our present value of our outflows at 10%, negative $4,932.23. Terminal value of the inflows at 10% is $5,500. MIRR 5.6%. You would not want to accept this. Why? NPV is obviously negative. Negative 386.78 is less than 0. And if you ran this into Excel, if you put those cash flows using the equals MIRR formula, MIRR is about 5.6%, which is significantly less than our cost of capital. Our cost of capital here is 10. So remember, anytime you have an IRR that is less than your cost of capital, you are losing money. And the same by the NPV method. If you have an NPV that is less than 0, you are once again losing money by taking this project. So anytime you have sign reversals, non-normal cash flows, MIRR is your way to go because it gives you one rate and one rate only instead of multiple IRRs at various points in the timeline. So that's going to take us to the very end of the chapter pertaining to capital budgeting and its related decisions.